5.1 exercises. Number 1. It's asking you to use your calculator to evaluate those expressions, so you simply put them in your calculator and get what it is. So 10, use that key for the power button. Your calculator may not look like this one. It may look like raised to the 0.5. So like this, instead of actually putting it up in the exponent. Whichever way it is, it doesn't matter. You just need to learn which way your calculator works. The next set of problems says to graph each function. Well, we just graphed 3 of them in the previous video, and the next problem asks us to graph as well. So 5 and 13 you can do, and you can check in the back of your book. So let's look at 25. F of x, which means function, equals 4 to the x power. And it asks us to do this in our calculator. So we're going to go to y equals, and we're going to go 4 raised to the x power, and we're going to zoom 6, and we're going to look at. So that's what we expected, because it was a positive exponent. It's going to be a growth, and that would be expected. Then it asks us to graph f of x, or sorry, y, and it wants us to take f of x, take this function, and add a constant, which is called c, a constant c. So that means that we would put into y equals 4 to the x power plus, we won't put c there, but the problem, if you look back at 25, it gives you 4 different values for c. So the first one we'll use is -5. That could be +5, or that could be -5. We're going to go to our next function, our y sub 2 function, and we're going to put 4 raised to the x power, and then we're going to say -5. Now, if you have the calculator in which the exponent is up top, make sure your -5 is big to the side, not in the exponent part. Now we can go to the side over here, and we can hit enter, and you notice how it changes that line to dark. So when we graph, we can see both lines, and we can see the only thing that changed is it moved down. Hence the -5. If we could see this much better, we can. 1, 2, 3, 4. You can see that that did move down 5 spaces. It asks us to say y equals 4x, and this time put -2 in. Well, if this moved it down 5, what do you think -2 or -2 will do? It's going to move it down as well. So we'll go and we'll put it in y3 this time. 4 raised to the x power -2. We can go over here and hit enter again, and it puts, oops, that's not it. There it is. Dotted line, and when we hit graph, there it comes. So yes, it from the original, it moved down 2 places. It wants us to do it with 6. What do you think is going to happen? It's going to move it way up on the picture. So 4 raised to the x power plus 6. And I'm just going to leave it as a line. Now we can see. So the constant makes the function move up and down vertically. It changes the y-intercept. If we were to look, let's look at if instead of changing, let's just get rid of these. Let's change the exponent. So if we go 4 raised to the x plus 2, what happens to our function? What happens to our graph? So there's the first one. And there's the second one. So instead of moving it vertically, this time it moved it, I believe I've got those backwards. Nope, this would be horizontally. And this would be vertically. So this moved it x, which is vertical, 2 places. And what was our function? Isn't that interesting? It's a plus 2, however, it moved it to the left, moved it negative places. So let's look and see what happens if it was a minus 2. So it moved it positively 2 spaces. So if we add to the function itself, it moves it up and down, horizontally per se. If we add or subtract to the exponent, it moves it side to side,